So this is Maths Genie's predicted paper for paper 2. If you want to go to the paper, go to mathsgenie.co.uk, go in the resources section and look at predicted papers, and the actual paper is in there. So question 1, it says there are only red counters, blue counters and yellow counters and black counters in a bag. The table shows the probability of picking at random a red and picking at random a black counter. Probability of picking the blue counter is twice the probability of picking the yellow. So basically we've got twice as many blues as there are yellows. So find the probability of picking a blue counter. So probability should add up to 1. So if we do 1, take away the 0.22, take away the 0.34, we get 0.44. Now because there's 2 shares of this blue and 1 share yellow, we need to divide this by 3. So 0.44 divided by 3. Now if you've got one of the calculators recommended in schools, that'll give you an answer as a fraction, but as a decimal that'll be 0.146 recurring. And because you're after the blue counters are 2 lots of that, so 2 lots of 0.146 recurring gives you 0.293 recurring. Now if your calculator gives that in a fraction, then this fraction was 11 over 75, and then that one would be 22 over 75, and that's absolutely fine. Either answer is correct. Question 2, a number y is rounded to 1 decimal place, and the result is 5.8. Write down the error interval. Well, the smallest number that will round up to 5.8 is 5.75, and the biggest number that will round down, or just less than that, will be 5.85. So it's got to be just less than that, and it can be that or just over. So the error interval is 5.75 to 5.85. Question 3. It takes 5 machines 6 hours to produce 1,000 DVDs. Work out how long it will take 4 machines to produce 1,000 DVDs. Well, the 1,000 DVDs here is just to tell you that it's doing the same amount of work. So we can actually ignore the number 1,000. They're both doing the same amount of work. So these 5 machines would take 6 hours. So 5 times 6 means there's 30 hours of work to be done. And if we're only doing 4 machines working, then those 30 hours of work need to be divided amongst the 4 machines, and that will give you 7.5 hours each machine. Question 4, it says a sphere is carved from a block of wood. The sphere has a radius of 5 centimetres and the density of wood is 0.85 grams per centimetre cubed. Find the mass to 3 significant figures. So really important, if you forget what the formula is for mass and density and volume, then this gives you a big clue. So 0.85 grams per centimetre cubed means that every centimetre cubed is 0.85 grams. So if we know the volume of it in centimetres cubed, we can times that by 0.85 to work out the mass. So the volume, we're going to use over here, we're going to use the volume formula. All right, we don't need the surface area formula, although they will give you that. So we're going to do 4/3 times pi times the radius cubed. And if you put that into your calculator, you'll get 500 over 3 pi. If we're going to times that by the mass, times that by the density, so 0.85 times the answer that we've just got. So we're going to try and use the answer button quite a lot in this, so we don't have to retype it out. That should give you 445 grams to 3 significant figures. So 445. Question 5, it says, an artist is making orange paint by mixing red paint and yellow paint in the ratio 8:11. Use this information to draw a graph of the relationship between the red paint and yellow paint. Well, obviously, if you had no red paint and no yellow paint, then you would be starting off here. And because the squares, I mean, you could go off and plot 8 and 11, which is just there, and so on, but the squares are quite small. So I'm going to times both of these by 5 and get 40 and 55, which will give me a cross up here. You can do as many of those points as you need, but then you're going to join those up with a nice straight line, using a ruler, of course. And it says the artist decides to use 50 mils of yellow paint. Use your graph to work out how much red paint you should use. So if we go to the 50 mils of yellow paint, which is just here, go across and read off. On mine, I've got 35 mils, but I think that's a little bit out because I was a little bit out up here. So I would probably say that was more like 36 or 37 on yours. So I'm going to put 35 because that's my graph, but if you use a ruler and a pencil, it should get somewhere probably between 36 and 37. Question 6, it says, work out the value of x. So first of all, in this triangle here, which x is involved in, we don't have enough information, we've only got an angle. So we need to work out this value here, I'm going to call it y. And that value y is part of this triangle here, which I can use Pythagoras in. So Pythagoras says that the hypotenuse squared is equal to the two smaller sides squared and added together. So that will give me that y squared is equal to 20 squared minus 16 squared. So that will give me 144. So y, if you square root 144, is 12. So y is 12. Once I've got that, I've got this the other triangle on the other side now. I've got x as the hypotenuse and y as the opposite angle, as the opposite side to the angle 25. So looking at trigonometry, Sokotoa, we can see that we've got the hypotenuse and we've got the opposite. So we're going to be using sin. So we're going to do sin 25 is equal to the opposite, which is 12, over the hypotenuse, which is x. So rearrange that, the x is going to come up here and the sin 25 is going to come down here. We've got 12 over sin 25. So x would be 28.4 to one decimal place. So 28.4 centimetres. Question 7. The diagram shows a parallelogram. All of the angles are in degrees. Find the value of x and the value of y. So straight away, we've got two values to work out here. So what a lot of students would do is add up all of these and put them equal to 360, because obviously this one would be equal to this one. But we're going to have an x and a y in that, which will be impossible to solve. So the first thing we need to realise is that these two are equal to each other. Okay, so the first thing we're going to do is we're going to put 3x plus 10 is equal to x plus 92. I'm going to solve that by taking an x off both sides, so that would be 2x plus 10 is equal to 92. So 2x will be equal to 82, taking 10 off, and then x would be equal to 41. So now I know that x is 41, I can substitute that into these. So 41 add 92 is 133, and this will be 133 as well. And we also need to know in a parallelogram that these two will add together to 180, because obviously these two will add together to 180 as well to make the full 360. So that means that 180 minus the 133 is 47. So the 3x plus 4y is equal to 47. And we know that x is 41, so 3 lots of 41 plus 4y is equal to 47. So that means that 4y will be equal to minus 76. I know that doesn't sound correct, but it is, because this will work out as being positive 47 when we work out the value of y. So y would be minus 19, and that's absolutely fine to have that number. So minus 19 for y. Question 8, it says solve the simultaneous equations. Now there's several ways of doing this, but what I've spotted here is that if I double the first one, then I'm going to end up with 4x's in both. Okay, so I'm just going to double the first one, which will give me 4x minus 6y equals 8. And I'm going to take that away from the second one, which was 4x minus y equals 13. So I'm going to take these two away from each other. So 4x take 4x is nothing, that was the whole point of doing it. Minus y subtract negative 6y would give me 5y's, because taking away a negative is like adding. And 13 take away 8 is 5. So nice and easy, y would be 1. I can then substitute that into any of these. I'm going to substitute it into the second one. So 4x minus y, so minus 1 would equal 13. So 4x would equal 14. So dividing by 4, x would equal 3.5. So we've got x is 3.5 and we've got y is 1. Question 9. It says, here's a graph of y equals x squared minus 2x minus 2. Write down estimates for the roots of that equation. Now it's an estimate because we're reading from the graph. So the roots are where it crosses the x-axis, so here and here. So that's about the middle of minus 0.5 and minus 1. So I'm going to do minus 0.75, but you can be a little bit out on that. And I'm going to do again 2.75 for that one there. It says write down the coordinates of the turning point for y equals x squared minus 2x minus 2. So the equation hasn't changed, so we're just going to work out the turning point of this graph here, which is just that point there. So that would be 1 minus 3. Question 10, it says ABCDE is a regular pentagon. So regular means all the sides and angles are going to be the same. BCF and EDF are straight lines. So work out the size of angle CFD. So CFD is this angle here. So we've got a triangle, and I could do working out this angle and this angle, so I can work out CFD. Now, if you notice, this angle here is actually an external angle for this pentagon, and so is this here. And we should know that external angles always add up to 360. So if we do 360 divided by 5, which will give me 72, that means that this angle here is 72 and this angle here is 72. So to work out CFD, so angle CFD will just equal 180 minus 72 minus 72, which will give me 36 degrees. Now it says you must show how you got your answer, but it doesn't ask for any reasons. So I've shown how I've done it because I've shown how I'm working out. So my answer is just 36 degrees. Make sure you look to see if it asks for reasons. Question 11. Prove algebraically that a recurring decimal 0.681 recurring can be written as 15 over 22. So the first thing to notice here is that the recurring symbols are just over the 8 and the 1. So if we write down what this is, you should always write down what the recurring decimal is, because you've got to prove that you know what it is. So x will be 0.6818181. The first thing I'm going to do is get rid of that 6. So I've got 6.818181, and now I've got a decimal where it's recurring just with the numbers recurring themselves without that 6 there. And now I want the 8 and the 1 to go over the other side as well. So I'm going to times it by 100, which will give me 1,000 x's, and that'll give me 681.818181. So the whole reason for doing that is that the 0.81's recurring are now the same. And if I take these two away from each other, I get 990x is equal to 675. So x will be 675 over 990. Now you've got a calculator, so if you put that into your calculator, it'll cancel it down for you. It gives you 15 over 22 just to check that that is correct. You should always write that that is equal to 15 over 22 at the end. Question 12. There are 12 boys and 15 girls in a class. One boy and one girl will be selected at random to represent the class in the student council. Work out the total number of ways of doing it. So for every boy, there are 15 girls. So for the first boy that I choose, there will be 15 girls to choose from with him. The second boy would have 15 girls. The third boy would have 15 girls to choose from, and so on. So the 12 boys each have a choice of the 15 girls to go with them. So we just do 12 times 15, which is 180. Question 13, it says the frequency table shows the speed of 100 cars. On the grid, plot a cumulative frequency. So the cumulative frequency graph means that we need to add up all the frequencies. So first of all, the cumulative frequency will be 6 for the first one, 23, 52, 77, 97 and 100. So we need now to plot these with the endpoints of each of these, because it means that there are 6 people that did 20 or less, 23 people did 40 or less, 52 people did 60 or less, and so on. So we plot them with the endpoints. So as accurate as I possibly can, we've got 8 with 6, and each little square is with 2. So it's going to go, apologies for that. It's going to go just here. So 20 and 6 will be just there. We're then going to go 40 and 23, which will be just in the middle of that one there. 60 and 52. So 52 will be just there. 80 and 77. So that will be just there. 97 with 100. So 100 with 97. So 97 is just there. And 120 with 100. So just there. So we join this up with a curve from 0, because all the points started at 0, as accurate as you possibly can. And that should be 2 marks. Find an estimate for the number of cars travelling over 90 kilometres an hour. Now, as I said earlier, all of these numbers here tell us how many did it in that speed or less. So we need to work out how many did it in 90 kilometres or less, and then take that off away from the total. So first things first, we're going to go to 90 kilometres an hour. And we're going to read off as accurately as you possibly can. And I think I was 1.5 squares down, so I've gone a little bit out there. So 1.5 squares down. So always be as accurate as you possibly can. So 1.5 squares down from there would be 87. And there were 100 cars altogether. So 100 minus the 87 would give me 13. Now, obviously, you're reading from a graph there, so you're probably allowed anywhere sort of between 10 and 15 on that one. Question 14. Using xn plus 1 equals 5 over xn squared plus 3, with x0 equals 1, find the values of x1, x2 and x3. Now, it sounds really confusing, this, but all you do is, to work out x1, you do 5 over, and you put x0 into this, so 1 squared plus 3. So that would be 5 over 4, or 1.25 if you put it in your calculator. x2, you would just do 5 over 1.25 squared, or you can just use your answer button. Plus 3, so it's best to use your answer button in this one, which will be 1.09589 0411, and always write down your full calculator display. And then x3 would be 5 over, and again use your answer button, so you don't have to write all that back in again, and that should give you 1.190199669. So writing these on the answer line, we've got 1.25, we've got 1.095890411, and then 0.1901999669. All right, always use your full calculator display. Question 15. It says Charlie invests £2,500 for 3 years in a savings account. She gets 3% per annum compound interest for the first year, and then X% for the next 2 years. And Charlie has £2,705.36 at the end of the 3 years. Work out the value of X. So if you invest £2,500, after 1 year, you'd multiply that by 1.03 to increase it by 3%. And then you would multiply that by some other interest rate squared for the next 2 years. So that's the bit that we're trying to work out. And that will give you £2,705.36. So first things first, I'm going to work out this bit, which would be 2575 times y squared gives you 2705.36. So to work out y squared, I'm just going to divide those by each other, 2575. So that'll give me, and square rooting that would give me y is 1.025. Now, it's asking for the interest rate, so the multiplier of a 1 is to increase it by, and 0.025 is 2.5%. So 2.5% is the interest rate for X. Question 16. If F is 9.15 to 3 significant figures and G is 22.06 to 4 significant figures, by considering bounds, so it's telling us what to do, we're going to use bounds, work out the value of H to a suitable degree of accuracy. So first things first, I'm going to rearrange this to become H equals the square root of G over F. So that's the formula we're going to be using because we want to work out H. And then I'm going to find the upper bound and the lower bound of that. So to work out the upper bound of H, I want the upper bound of G. So that would be, so G is 22.06, so that would be 22.065, and we're square rooting that. And I want the lower bound of H. So the lower bound of H will be 9.145. All right, so I want the biggest number on the top and I want the smallest number on the bottom, and that will give me the biggest possible answer. So that will give me 0.5136511,397. To find the lower bound of H, I want the smallest possible number on top, so that'll be 22.055, and I want the biggest number possible on the bottom, so that'll be 9.155 for these bounds. Okay, so to find the lower bound, put that all in, and we should get 0.512 97,37979. Now, when it says by considering bounds work out the value of h to a suitable degree of accuracy, what it's after is what both of these numbers are to the same. What both of these numbers are the same to. So if you look, we've got 0.51 and then 3, and then we've got 0.51 and then a 2. So the suitable degree of accuracy, both of them are round to 0.51. So 0.51 would be to two significant figures. Would be the suitable degree of accuracy. So they're both round to 0.51. Question 17, it says, for all values of x, f of x is 5x minus 2 and g of x is x squared plus 2. Find f of 3. So all that means is put 3 in for x. So 5 times 3 is 15, take away 2 is 13. Apologies. 13. Find f g of x. So f of g of x means we're going to put the function g of x into f where x is. So I'm going to do 5, and then where the x is, I'm going to put the x squared plus 2. And then obviously I've got to take 2. So all I've done is I put x squared plus 2, that's g of x, in where x is. And then expand that out. So that'll give us 5x squared plus 10 minus 2, which will give us 5x squared plus 8. It says solve f g of x equals g f of x. Now we've just done f g of x, so we now need to work out g f of x, and we'll do the opposite thing. So we put 5x minus 2 where the x is in g of x, so squared plus 2. And to solve that, that would be 5x minus 2 brackets 5x minus 2, and then don't forget your plus 2 on the end. So that would give you 25x squared minus 10x's minus 10x's plus 4 and then plus the 2, which will all simplify down to 25x squared minus 20x plus 6. So we now want to put these two equal to each other. So we've got 25x squared minus 20x plus 6 is equal to 5x squared plus 8. And to solve that, we obviously want it equal to 0. So that will give us, 20x squared minus 20x minus 2 equals 0. And because these are all even, I can do a little trick. I can divide all these by 2 just to make my numbers a bit smaller. So that gives me 10x squared minus 10x minus 1 equals 0. Now, to solve that, I'm going to put it in the quadratic formula. And the quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. You need to know that off by heart. Where a is the number in front of the x squared, b is the number in front of the x's, and c is the number on its own at the end. So we're going to have minus 10 plus or minus the square root, of minus 10 squared. Make sure you put that in brackets because minus 10 squared would be a positive 100. Minus 4 lots of 10 times minus 1. All over 2 lots of a, so all over 2 lots of 10. And if you put that into your calculator, you should get x is 1.09 or minus 0.09 to 2 decimal places. Question 18. It says, the table shows information about the speed in miles per hour of 120 cars. On the grid, draw a histogram, and you'll notice we've got nothing on the axes here, so we need to label it all up and everything. So to do a histogram, we need the frequency density, and the frequency density is the frequency divided by the class width. So the class width for the first one is 15, so I'm going to do 6 divided by 15, 10 divided by 5, 46 divided by 5, 48 divided by 10, and 6 divided by 15 to get my frequency density. So that'll give me 0.4, 2, 9.2, 4.8, and 0.4. So now I need to put this into my histogram. We're going to have speed across the bottom, and the speed needs to go up to 90, and it needs to start at 40. So I'm going to start at 40, 50, 60, 70, 80, and 90. Now really, you shouldn't really start at 40 there, but it only just fits on. In the exam, there'll probably be an extra square, so you could start at 0, do your little squiggly line to show that you're not starting, you don't want to start at 0, and then go to 40. And then up the side, I want to do frequency density. So frequency density, again, we're going to start at 0, and I've got to get all the way up to 9.2. So this just gives me enough space just to get up to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So that means each little square is worth 0.2. So from 40 to 55 is 0.4, so that's going to be 2 little squares wide. Tall, so that will go to there. From 55 to 60 it needs to go up to 2, so that's going to go to there. From 60 to 65 needs to go up to 9.2, so 9 is just there, it's 1 little square above, so as accurate as you possibly can. And then 65 to 75 is 4.8, so 4.8 is just going to be 1 little square below there, up to 75, and then 75 to 90 is at 0.4. So there you go, that's your histogram. It says work out an estimate for the number of cars that travel over 70 miles an hour. So over 70 miles an hour is the area of all of this here. Okay, so the first bit is 5 wide and 4.8 tall, and I want to add to that the last one, which is 15 wide and 0.4 tall. So you put that into your calculator, you should get 24, add 6, which gives you 30 cars travelled at more than 70 miles per hour. Question 19, it says, here is the first 5 terms of quadratic sequence. Find an expression in terms of n for the nth term of this sequence. So the sequence goes 4, 8, 15, 25 and 38. Now quite a lot of you have been using a new method to me, which Hegarty shows, and a lot of you have been revising that, and it tells you that the first term in the sequence is a plus b plus c, where similar to the quadratic formula, it's an squared plus bn plus c. So the a is the number in front of the n squared, the b is the number in front of the n, and the c is the number on the end. If you do the second difference, so the second difference is 4, 7 and 10. The first number in the second difference is just worth 3 a's plus a b. And then if you do the second difference, which is just 3, that number is worth 2 a's. So straight away, if 2a equals 3, I know that a equals 1.5. So I know that a is 1.5. I can then substitute that into this one. So I've got 3 lots of 1.5 plus b is equal to 4. So 4.5 plus b is equal to 4. So b is equal to minus 0.5. And then I know that a plus b plus c is equal to 4. So that's 1.5 take away 0.5 plus c is equal to 4. So that will give me that c is 3. So putting that back in, I've got 1.5 n squared minus 0.5 n plus 3. So that's using the method on Hegarty for this. So in class I've shown people a different way where you work out the second difference and half it. That will give you the quadratic part, and then you subtract the quadratic part from the sequence to give you the linear part, and you find the nth term of the linear part. It will give you the same answer, but I actually quite like this method, so I thought I'd show you in the video. Question 20, it says, here is a speed time graph. Use 3 strips of equal width to find an estimate for the area under the graph for the first 3 seconds. So we're only going up to 3 seconds, and we want to split into 3 equal width strips. So we're going to do 1 second per strip, and we're working out the area under the graph. So if I go from here to here, I've got a triangle just there. From here to here, I've got a trapezium, and from here to here, I've got another trapezium. Okay, so I call that 1, that 2, and that 3. I want to work out the area of these 3 shapes and add them together. So shape 1 is half times base times height. So half times 1 times 2, which will give me 1. Shape 2 is a trapezium, so it's a half times a plus b. So that'd be 2 plus 3.3, because this one goes up to 3.3 just here. Times by the height, which will be 1, and that will give me 2.65. And then shape 3, again, it's half a plus b times h. So sorry, a is 3.3 again, and B is 3.9, and again times by the height, which is 1, and that gives me 3.6, and you add all these together, that should give me 7.25. Now again, because you're reading off a graph here, you'd be given a little bit of leeway either side of that, but I think 3.3 and 3.9 is perfect for those. Describe what your answer to part A represents. Well, the area under a distance time graph is the distance travelled. So it is the distance travelled in the first 3 seconds. Question 21, it says, work out the perimeter of triangle ABC and give your answer to 3 significant figures. Well, you can see here that we've got opposites. So we've got a side with its opposite angle, and we want to work out this side here, which I'm going to call X, and we need to work out this side here, which I'm going to call Y, and we've got these with their angles as well. So if that's 105 and that's 48, that means that this is 27 degrees. So because we've got all 3 angles, we can use the sine rule to work out X and Y. So I'm going to work out X first. So X over it's the sin of its opposite angle, which is 48, is equal to 13.1 over the sin of its opposite angle, which is 105. So X would be 13.1 over sin 105 times sin 48. And that should give you 10.07861 and that's in centimeters, sorry, in meters, isn't it? To work out Y, we've got Y over sin 27, so sin of its opposite angle, is equal to 13.1 again over sin 105. So Y would be 13.1 over sin 105 times sin 27 in this case, which should give you 6.1572712 meters. And to work out the perimeter, you're going to add all those up. So 13.1 plus the 10.07. Just leave that in your calculator using the memory button, and 6.157 and so on. And that should give you 29.3 meters to 3 significant figures like it asks. So 29.3 meters. Question 22. It says OA is 5A, and that's labelled on the diagram. OB is 3B, that's also labelled. C is the point on OA, such that OC to CA is 4:1. So that means that if C is just there, splitting that in the ratio of 4:1, usually I'd do that as a fraction, but actually it's a nice number. So splitting 5A's into the ratio of 4:1, that means that this is 4A and this is A. And M is the midpoint of AB. D is a point on OB, such that OB to OD is in the ratio of 3:4. So OB is 3B's, and O to D, the full way, will be 4 parts. So if this is the 3 parts, which is 3B's, all the way will be 4B's, which means that this bit here must just be a B. Show that C, M and D are all on a straight line. So to do that, we need to work out CM and MD and show that they are parallel and that they share the point M. So first of all, I'm going to work out AB, because we need AB to be able to work out the AM. So AB is equal to minus 5A's, because we're going down this way, plus 3B's. So we've got AB. To work out CM from there, we're going to go from C up to A, which would be an A. And then we're just going to go down AB, but we're only going to go halfway. So that'd be plus a half of what we just worked out, which will give me, sorry, 3B's. Which simplified through CM would be minus 3 over 2 A's plus 3 over 2 B's. So you've got a half of 5 A's is 2.5, so A take 2.5 is minus 1.5, or minus 3 over 2 A's. And a half of 3 B's is 1.5 B's, or 3 over 2 B's. So I've just kept that as improper fractions there for you. We then want to work out MD. So to work out from M to D, we're going to go from M down to B, which again is a half of minus 5A's plus 3B's. And then from B to D is plus that B that we worked out earlier. And if you simplify all that through, you should get 5 over 2, sorry, minus 5 over 2's A's plus 5 over 2 B's. Now you can see that they've both got the same number in front of the A and the B's. So this one would factorise to 3 over 2 minus A plus B. And this one would factorise to 5 over 2 minus A plus B. So they've both got the minus A plus B and they're just different lengths. So they are parallel. And they also share the point M. So that means that they must be on a straight line. So CM is parallel to MD and they share the point M. Therefore, CMD must be a straight line. Question 23. It says there are some red counters and some blue counters in a bag. The ratio of red counters to blue counters is 4:1. 2 counters are removed at random and the probability that both counters are red is 22 over 35. Work out how many blue counters are in the bag. So first of all, we know that there are 4 X red counters and there are X blue counters. It doesn't mean that there are 4 reds and 1 blue. It can be any multiple of that. So I'm going to call it 4X and X. So looking at a tree diagram, where we've got red on the top and blue on the bottom, it'd be 4X over 5X. Now that cancels down. We can just cancel the X's out to 4 over 5. And obviously blues will be 1 over 5. Now if we go on to the second branch, where we've got red and blue, red and blue. So the probability of getting a red would be 4X minus 1, because we've already taken a red out, over 5X minus 1, because now 1 less counter in the bag. And so on. We could do the same all the way down. So we've got X blue counters still over 5X minus 1. We've got, if a blue comes out first, we'd still have 4X red counters over 5X minus 1. If a blue came out first, it would be X minus 1 over 5X minus 1. However, we're only after a red and a red. So a red and a red has a probability of 22 over 35. So that means if we multiply these together, the red and the red, so the first red is 4/5, and we're going to times that by 4X minus 1 over 5X minus 1, and that will equal 22 over 35. To multiply fractions, you just do top times top. Sorry, so that'd be 4 brackets 4X minus 1 over 5 brackets 5X minus 1, and that would equal 22 over 35. We can then multiply both sides by, I'm going to take this 35 up here, I'm going to take the 5 brackets X minus 1 up to the other side, and that will give us 140 4X minus 1, and that would be equal to 110 brackets 5X minus 1. So I've just taken the 35 up and the 5 brackets 5X minus 1 up. I can divide through by 10 there, so that'll give me 14 brackets 4X minus 1, just to make it a bit simpler, equals 11 brackets 5X minus 1. So you didn't need to do that step, but that just makes things a little bit simpler. When we expand out, that'll give us 56X minus 14, and that will give us 55X minus 11. Take the 55X off both sides, I'll have X minus 14 equals 11, minus 11, and then add the 14 to both sides to get X equals 3. Now the X is the blue counters, and we are after the blue counters, so we don't need to do anything more with that. X is just equal to 3.